This question says to use L'Hopital's rule to determine the following limit. Okay, we got to be clear. What is L'Hopital's rule? It says when you have 0 over 0 or infinity over infinity, then at that time, take the derivative of the top and the bottom separately. And the separately is kind of the key word. Okay, so they're telling us to use Lopi, so we've got to have 0 over 0 infinity or infinity, which means we've got to have a fraction, don't we? And this is not a fraction. So we've got, our first step is to take this and change it to a fraction. So how are we going to do that? Take the limit, x goes to 0 from the right. Got to make it a fraction. So I'm going to put the L and x there, and I'm going to grab this x and jump it to the bottom as 1 over x. So are you aware that that's really the same thing? When that 1 over x jumps to the bottom like that, that's exactly the same thing because to multiply by x is the same as to divide by 1 over x. It's exactly the same. Let me prove it to you with numbers. If I take 10 and divide it by 2, that's 5. That's the same thing as if I take 10 and I multiply it by a half. It's still 5, right? So in other words, dividing by 2 is the same as multiplying by the upside down of 2, isn't it? So multiplying by x here is the same as dividing by 1 over x. Dividing and multiplying are just upside down operations. So that's a big fancy plastic surgery is what I like to call it, right? Just to help it stick in your mind. It's like we remove the wrinkles, but it's the same person, right? We made this thing look different, gave it a new look without changing the value. By putting the 1 over x on the bottom, that's the same thing as a regular x on the top. Now you can flip it back up, be x over 1, same thing. Right? And why would we do that? Well, because we have to make it a fraction for L'Hopital's rule. That's so much of what we do in math and science. Somebody gives us a rule like L'Hopital's rule, and then they give us something to solve, and we got to make it look, we got to give it a new look so it looks like what our rule says it's got to look like, and that is it's got to be a fraction. So I made it look like a fraction without changing the value. Now let's plug in the 0 from the right, 0. So what are we going to get? Natural log of 0. Now, I know that's confusing. It turns out, I'll just tell you, it's negative infinity. Now, why is it negative infinity? Well, if you just type in, let me go to calculator and help you with this. You just type in, whoops, that's not the right one. You just type in natural log of 0. Here, let me come up here and just do it. It's going to go air, undefined, right? So, but that's why it's at 0 from the right. So it's just a little bigger than 0. So if you make it like 0.000000001, look at that now. It's negative 46. And you think, well, what's that, infinity? How's that infinity? Well, do more zeros. Zeros, a whole bunch of zeros. 1. Negative 9. See, it's getting bigger. It's getting bigger. As that number gets closer and closer to 0 from the right, the natural log is going further and further down. The other thing you could do is I could just show you on a graph. Here we go. Let me just show you on a graph real quick, on a Desmos graph. I come up here and I go, okay, y equals, and I go natural log. Where's the natural log? Function. No, I don't know. Well, functions, I guess, functions. Natural log. Hey, natural log, where are you, man? It's a pain. Natural log, there it is. Natural log of x. There we go. There's the graph of that. So look at that. So as x gets close to 0 from the right side, it takes a dive down to negative infinity. All right. That's that's negative infinity. Now on the bottom, we got 1 over 0. What's that? Well, that's infinity also, right? Because remember when the bottom of a fraction goes to 0, I have like 1 over 0. Remember, because a fraction means bottom into top. Well, 0 goes into 1 infinite times. So I'm getting infinity over. Don't worry about negative, positive, whatever. You get any kind of infinity over infinity. First off, that's indeterminate. You might think, oh, I know what that is. That's -1. No, no, no. No, it's indeterminate. It means we can't determine what it is. We're not clear. Again, you might say, well, they cancel the infinity. No, it depends how fast they're going. If this function go, if it's like if you send two rockets up one's going up twice. They're both going up forever. One's going twice fast as the other. The gap between them or the divide, it's not going to be the same. So it's indeterminate. We cannot determine it. It's not clear. Infinity, infinity. Then we can do L'Hopital's rule, which says what? Take the derivative. So I'm going to do that. So now I'm going to use L'Hopital's rule, which means what I'm going to do? I'm going to do the derivative of the top and the bottom separately. So I'm going to go, okay, derivative of the top and the bottom. So move down here separately. So this becomes the limit as x goes to 0 from the right. So just the top. So what's the derivative of natural log of x? Well, it's 1 over x. We know that one, right? And what's the derivative of the bottom? This 1 over this is x to the minus 1, right? So what's his derivative? Minus x to the minus 2. Now I didn't do quotient rule there. You're probably going to think, oh, you can fraction, you do quotient rule. No, I'm not doing quotient. I'm doing L'Hopital's, which is separate, right? Because quotient rule, you got to do, they got to take turns and you got to divide by the denominator squared. No, that's not what I'm doing. I'm doing L'Hopital's, which is top and bottom separate. I did just the top, just the bottom separate. Okay, so what? What does all that mean? Well, and now you need to clean this up. I'm just gonna write clean up. How do you clean this up? Well, just keep the limit sitting there in the front for the moment. And then you remember what a negative power does. It's going to jump to the top, then become positive, right? Negative powers jump to the other side, then they become positive. So it goes times, and then this is going to be negative x to the positive 2 all over 1. There's nothing down there anymore. Does that make sense? So whenever don't confuse a negative in the front from a negative in the power. Negative in the power jumps. If it's on the top, it jumps down. If it's on the bottom, it jumps up. They're unhappy where they're at. They want to jump to the other side. Then the power becomes positive. The negative in the front of it just sits there negative. Okay, great. So what? What is that? Well, then that is the limit as x goes to 0 from the right of, get rid of that. We don't need that 1 on the bottom. It's not doing anything. So we have 1 over x times negative x squared over 1. Really, just put that over 1, right? It's x squared. And so, and you know what that means, right? Uh, x squared is xx, so this one cancels that one. So it's the limit as x goes to 0 from the right. What do we have left here? Just negative x, right? That's all we got left. Everything else canceled out. All right, plug in that 0. X is going to 0. Plug in that 0. It's negative 0. It's 0. After all that, it's just 0. That was a lot of work to get 0. And so there we go.